So in video 2 of linear recurrence relations, solving them, we looked at solving a homogeneous linear recurrence relation. We want to continue doing that now. Later down the road, we're going to look at the non-homogeneous type. They're a little more complicated. For now, we just want to focus on doing the homogeneous type. Let me do a few more examples of those. Let's just say we want to solve the following. Here we go. A sub n is equal to a sub n minus 1 plus 6 times a sub n minus 2. So that's the recurrence relation. This is for n greater than or equal to 2. And then we have some initial terms. A0 is 3 and a1 is 6. Now that's the way the recursive sequence is defined. It's linear, right? The powers on the a terms, the aj's, is 1. It's homogeneous because all you have is those a terms, right? an minus 1, 6an minus 2. You don't have any additional terms besides the aj's. It has constant coefficients. So first of all, we want to look at the characteristic equation. Get a pen here. I guess I'll do it in red. Characteristic equation. That's the first thing you always want to do. So this guy has degree 2. Why? Because it ends with the n minus 2 situation. The 2 there indicates degree 2. So you're going to have r squared equals, the coefficient here is going to be 1 because there's a 1 in front of the an minus 1. So r, 1r, plus, and then 6 ends with a 6. So that's a plus 6 because we had a plus 6 in front of the an minus 2. All right, so we want to solve that. So we're going to subtract r from both sides. We're going to subtract 6 from both sides. We're going to get 0 on the right when we do that. We're going to factor 2 pairs of parentheses equals 0. We're going to have r times r squared. And then we're going to find two numbers that multiply to give negative 6 and add to give a negative 1. Let's say negative 3, positive 2 do the trick, right? Negative 3 times 2. Negative 6, negative 3 plus 2, negative 1. Set your factors equal to 0. R minus 3 is 0, R plus 2 is 0. That's by the 0 factor property or 0 product property. You get R equals 3 for your first root, R1. And for your second root, R2, you're going to get negative 2. So what we want to do next, we want to write down the form of our solution. Form of our solution, we'll go blue for that. Form of the solution. It's going to look something like a sub n. This is the closed form of the sequence. Alpha 1 times your first root to the n power plus alpha 2 times your second root, which is negative 2 to the n power. So the only real task that we have to do here is finding this alpha 1 and alpha 2. And we're going to do that. I'll do it here on the side. We're going to find alpha 1 and find alpha 2. And these are based on, hold up, alpha 2, not A2, alpha 2, difference. These are based on your initial conditions, right? Alpha 1 and alpha 2. Your initial conditions, right? So you, hold up a second. So you have to go back to, come on now, don't do this on me. Don't do this on me. What the hey, man? Yeah, there we go. You have to go back to your initial conditions. What were they? What were our initial conditions? Well, they're right here. Let's get a highlighter and highlight them right here. Alpha 0 is 3. Alpha 1 is 6. Scroll, please. Thank you. So, we had A0 is 3, not alpha 0. A0 is 3. A1 is 6. So I'm going to use that fact here. Let's use a little green. Use a little green. So here is A0 is equal to, I'm going to actually put it on this right-hand side. A0, remember, was 3. And A1, that's equal to 6. All right, those were our initial conditions. Now, what I'm going to do, I'm going to plug 0 in for n. I'm going to plug in 0 right here in for n in the form of my solution. So I'm going to end up with alpha 1 times 3 to the 0 power plus alpha 2 times negative 2 in parentheses to the 0 power, right? We're just plugging in 0 in for n, right? 0 in for n in the form of the solution. Then our second equation, notice A1 is equal to 6, so we're going to plug in 1 for n in the form of the solution. So we're going to have what? Alpha 1 times 3 to the 1 power plus alpha 2 times negative 2 to the 1 power, right? We're plugging in 1 for n, right? This a sub 1, we're plugging in 1 for n in the form of our solution for the n's. All right, so this is going to give two equations here, right? It's going to give alpha 1 plus alpha 2 equals 3, right? 3 to the 0 was 1. Negative 2 to the 0 was 1, so we're just going to have alpha 1 times 1 plus alpha 2 times 1 equals 3. So alpha 1 plus alpha 2 is 3. And then the next equation, we're going to have, what, 3 alpha 1 minus 2 alpha 2 equals 6. Why? Because 3 to the 1 was 3. That'll be the coefficient of the alpha 1. Negative 2 to the 1 is negative 2, which is the coefficient of alpha 2. So we want to solve this linear system. So how can you solve this linear system? Well, there are different ways to do it. I can multiply the first row here, the first equation, multiply it by 2, multiply by 2. If you do that, you're going to have what? 2 alpha 1 plus 2 alpha 2 equals 6. And I'll keep my second equation the same, 3 alpha 1 minus 2 alpha 2 equals 6. And we're going to scroll, we're going to cancel out, right? We're going to add those two equations now. And when we do that, we're going to get, what, 5 alpha 1, and we're going to cancel out the 2 alpha 2 and the negative 2 alpha 2. So we'll get 5 alpha 1 equals 6 plus 6, 12. That'll give us alpha 1 is 12 over 5, right? 12 over 5. So once you have alpha 1 is 12 over 5, you can find alpha 2, right? If you go back and plug into the very first equation right here, we're going to have, what, 12/5 in place of alpha 1. 12/5 plus alpha 2 is 3. Scroll a little bit more. Come on, you can do it. This is going to give, what, alpha 2 equals, subtract 12/5 from both sides, 3 minus 12/5. That's going to be, well, 3 is the same thing as 15 over 5. 15 over 5 minus 12/5 is 3/5. So alpha 2 is 3/5, it looks like. Okay, so now we're just going to plug those numbers into our form to get our actual solution. So remember, alpha 1 was 12/5, alpha 2 was 3/5. So here's the actual solution. Come on. I'll just write the solution here. Solution, the actual solution, would be A sub n equals, which one was 3/5? Was it alpha 1 or alpha 2? Alpha 1 was 12/5. 12/5 times 3 to the n power plus 3/5, right, that was alpha 2, times negative 2 to the n power. So this is actually the closed form. The closed form of that sequence. So if I wanted to calculate a sub 100, rather than having to go through the recursive definition, it would be a step-by-step process. I could immediately just plug in 100 here for n, and it'll give me an immediate output. Of course, doing that in a calculator may not work, right? 3 to the 100th power would be enormous, but who knows? All right, another example. Another example.